Find the volume of a solid obtained by rotating the region in example 6a about the line x equals -1. So 6a, if we look back, was the area between y equals x and y equals x squared, right? And we've done that a couple different things. First, we rotated that around the x-axis. Then we took that and we rotated it around the horizontal line, y equals 2. So when the radius had to be measured from that line. Now I want to rotate it around x equals -1. What kind of line is x equals -1? Vertical line. Okay. So we're doing this one a couple different ways. Oh, I don't know where all those extra. Okay. So x equals -1. Here. That's what we're going to rotate around. We've already talked about this intersection a few times. So we found that y equals x and y equals x squared. Remember, we had to find when they were equal to one another. So that's, we got 0 and 1 for the intersection points back when we did it the first time. So if you put in 0, you get out 0. If you put in 1, you get out 1 for both of those. If you put in 1/2, then the line gave you 1/2, but the parabola gave you 1/4. So it was y equals x on top, and y equals x squared was on the bottom there. Okay, that's a really bad sketch. I'm sorry. So now, if I rotated that around the line x equals 1, when I'm doing these rotations, I first think of it kind of like a reflection. And so this point would come here, goes here, it was line on top and the curve on the bottom. And then I just kind of connect them, so as it spins around, it's making just this bowl shape. So it's solid on the outside and hollow on the middle. Now, because I'm rotating around a vertical line, would I integrate with respect to x or y? With the y's. Okay. So, we're going to do the integral. Since everything is a y, my bottom has to be the lowest y value. So where does this start? When y is 0, and it stops when y is 1. Okay, then we have pi. Because there are two curves, remember we had to do the outside radius minus the inside radius. Okay, but we have to think about that more because we are not rotating around the axis. So if I'm starting here, then my radius would go all the way out to here, right? How far is it from here to here? How far is it from here to here? That's x squared, right? If I'm doing that in terms of y, then it's the square root of y. So it would be, the radius would be 1 plus the square root of y.
Wait, why do we do it like that?
Why do we add the 1, or why do we do it with the y as the variable?
With the y.
Anytime you're rotating around the vertical line, we had to keep y as our variable.
So why didn't you put like x squared plus 1 equals y? Why only x squared?
The original graph, that black line we drew to start with, was the x squared. So that's why I knew from here to here, that point is x squared, or the square root of y. So the total radius became 1 plus the square root of y.
Okay, so.
And then we're doing area, so pi r squared. So it'd be 1 plus the square root of y squared. Now, we have to subtract off because, hello, come on in.
She's so quick about it too.
She's gonna kill me.
So we have the outside one, and then we need to subtract the inside one. So let's think about this inside one. So it's still, from here to here is still 1. Then from here to here. We're going to the line. The line was y equals x, so that part would be y. So the inside radius would be 1 plus y. And then we have to square it. And then what goes at the end?
dy.
dy. Everything has to be in terms of y. Okay, I would recommend multiplying this out and combining like terms before you try to do an antiderivative. I'm going to pull out my pi. So if I FOIL, we get 1 plus 2 radical y plus the square root of y squared is just y. Minus, FOIL these, we get 1 plus 2y plus y squared. dy. So, combine my terms, 1 minus 1, that drops. I have a 2 radical y, so 2y to 1 half. Y minus 2y is negative y minus y squared dy. So now let's do the antiderivative. Antiderivative of 2y to the 1 half. So if you add 1 to your power, it would be. So then we need a 2/3 in front times the 2 that's already there is a 4/3. Minus antiderivative of y. Yep, I don't know why I put a 2y squared. Minus antiderivative of y squared. 1/3 y cubed. Once you evaluate from 0 to 1. And we get alright. So, are you guys seeing the difference when we do it in terms of y and when we do it in terms of x? When we're rotating around a horizontal line, the y's change, but the x's are fixed. We're starting from here and going till here. When we're rotating around a vertical line, the x's are changing, but the y is fixed. We have a lowest and a highest. So that's how you know what variable to keep it in terms of. All right, let's do another one. This one may test my art skills. Okay, let f of x equal 5x and g of x equals x squared. And R is the region between the graphs of f and g on the interval 0 to 3. So I even gave you a starting and a stopping point. Find the volume obtained by rotating R about the x-axis. So if I'm rotating around the x-axis, what variable are we keeping? X. We're rotating around a horizontal line, so we'll do it in terms of x. Okay, so we need a graph. We're going from 0 to 3. So if we put in 0, 5 times 0 is 0, to 3, 5 times 3 is 15. I'm going to count by 3s. Alright, so there's my line on that interval. And then g of x equals x squared. So 0 squared is 0. 3 squared is 9. 2 squared is 4. That. 1 squared is 1. So they don't actually meet at the end, but that's where I'm stopping it. So we are taking this region, rotating that around the x-axis. So if I'm trying to draw a picture, I usually draw a reflection first and then make it a rotation. Okay. So we're getting something like this. So when I integrate, if we're doing it in terms of x, my starting and stopping are my x values. Where do we start and stop? Okay. These were circles when you looked at the cross section, right? Every circle is pi r squared. So when we do this, we keep the pi out. And we do the outside minus the inside. So the outside circle, so think the radius would go from here all the way up. And that was the line y equals 5x. So my outside circle would have a radius of 5x squared minus the inside circle. That goes to our parabola. Minus x squared. We get 25x squared minus x to the 4th. Just because everything we've been looking at is circular, I just wanted to show you that it doesn't have to be circular. So I had to throw one in just for fun. So suppose a pyramid is 4 units tall, has a square base, 3 units on the side. Find the volume of the pyramid. So, finding my volume. What's a pyramid look like, first of all?
Triangle.
Box.
Oh, that's really bad. A box triangle. Because it had a square base. My triangle drawing is,
Right, so it has 4. Okay.
so there are 4 sides here. Okay, I told you it was 4 units tall. The base was square, so each side of our base was 3. Okay, so if we were going to integrate, is this like a vertical or a horizontal type thing? A vertical, right? So where do you think, if we're doing it vertical, we have to have y values. What's the lowest y value, do you think? And the highest would be 4, because that was the height. And it would be a dy. Okay, and then what shape would a cross section have? So if you took a slice, it's a square. So cross section would be like this right here. So that's square. How do you find the area of a square? Length times width. Okay, so I need to figure out some kind of expression for that square right there. So let's see what we can do. Let's talk about the whole thing. I took this whole triangle. The height is 4 and the base is 3, right? If I take a cross section, then I get a little triangle formed right here. Agreed? The triangle that we basically cut off the top. What if this is the height of 0? What would this height be? Except vertical, so variable would be y. So the total height was 4, so you could get this little piece. If this is y, this would be 4 minus y. Okay. And do we know what this length would be? So let's call that x for a moment. Can't we use similar triangles here? So we could like say 3 over 4 equals x over 4 minus y. X is the length of the side we need, so we have to get that by itself. So if you multiply over the 4 minus y, x is 12 minus 3y over 4. Or if you reduce that, 3 minus 3/4 y. So we solve for the x. Okay. So now, before we integrate, we need a FOIL. So we get 9 minus 9 half y, 16y squared. So antiderivative of 9 would be 9y. Antiderivative of 9 halves y would be 9/4 y.